All right. So we are going to do Objective 6 today. We are going to add and subtract rational expressions. What's rational mean? Fraction. What do we know about adding and subtracting fractions? Common denominators. Okay, so we are going to start with monomials, and we are going to work our way up into binomials and trinomials. Okay. So first things first. This is my key to success. Is to draw your blanks and set up your problem. Okay? Draw your blanks and set up your problem. That will help tremendously. And this is what I mean, draw your blanks. So we're going to have to change our fractions right here to have common denominators. So I'm going to draw what my new fractions are going to be, and I can't just magically change. If I'm going to change 2y to a common denominator, I can't just bring it down and change it. I've got to multiply by something on either side, so on both sides, to change it. So there's where I mean draw your blanks. Every problem will look like that. Okay, set it up, draw your blanks. Probably, yeah, you'll probably have to scoot it over, and that's a good thing. Don't try to squeeze it on the end, so you probably need to, that's why I moved my problem to the center of my paper. Okay, sorry about that. That's a good thought there. Yeah, you're going to have some space. Okay, if you're just tuning into us, we just had a discussion that prepare yourself. Each one of these problems will probably take about a half a sheet of paper. So prepare yourself for this. All right. Let's see if we can find a common denominator. Now, do realize monomials are slightly different. They're going to be different than our binomials and trinomials. So monomials, let's just look at our numbers. Okay, let's go back to middle school. What's the common denominator of 3 and 2? 6. Okay, we got that. So monomials you treat like normal, 6. Now, as far as our variables go, here's what I'm going to tell you. I always pretend in my little crazy head, and y'all are starting to realize that my head is pretty crazy these days, but I imagine that I'm really hungry on a menu, and I'm looking at my menu up there being my fractions, and I want to pick one of every variable I see to be in my common denominator. Does that make sense? I'm going to pick one of everything. Okay, so get your menu and pick one of everything. What variables do we see? I see an x, so you need an x. And I also see a y. You need at least one of everything you see. Okay, does that make sense? The other conversation that I'm going to have with you is that, like, let's say this guy, I'm going to pretend, you don't need to write this down. Let's say this guy has an x squared on it. The question is, he has an x squared, how many do you need? You actually got to have the most, think bigger, you know what I mean? Like the 3 and the 2, we went bigger and went with 6. Okay, you need the most amount you can get from each individual thing. Does that make sense? So if he has one set of x's and this guy has an x squared, then you would actually need x squared in your common denominator. My mama always told me to pick the biggest one, and you are it. Does that make sense? You pick the bigger of the two. Okay, pick the bigger. You would actually need an x squared. Now, what if I just had an x? What if he had an x and he had an x? Would you need 2? You would pick the largest amount anyone has. If he only has 1 and he only has 1, then how many do you need? You only need 1. Does that make sense? So we'll talk more about that. Whoops. Let's take that x away. Okay, let's keep rolling. Everybody understand how I got 6xy? 2 and 3 both go into 6, and you have to have an x, and you have to have the y. Okay, you got to have at least one of everything you see. Okay? All right, now, I can't just magically change that denominator to that denominator. Something has to happen. Okay, I have to multiply 3x by something in order to change it. So what do I multiply by 3x to get to 6xy? 2y. And guess what? If I multiply by 2y in the denominator, guess what I got to do? I've got to multiply by 2y in the numerator. What you do to the bottom, you must do to the top as well. Okay? What about on this side? What do I need to multiply by 2y to get to 6xy? All right, so what do I need to multiply by? 2y times what? 3x. Oops. We're going backwards again. 3x. Everybody understand how I figured out? I said what? 2 times 3 would be 6. And I've got the y, but I also need to multiply by the x. Okay? So at this point in time, I'm going to multiply these together and change my numerators. So what is 2y times negative 7xy? Xy squared. Very good. Okay. What is 4y squared times 3x? 12xy squared. Now, all I've done right now is I have successfully made common denominators. That's all I did. I chose my common denominator, and I figured out how to change my numerator. And now I have common denominators. If you have common denominators, you simply just add them together. Now, are these like terms? This is a xy squared. This is a xy squared. Are they like terms? So I can take these and add them together. What's negative 14xy squared plus 12xy squared? Negative 2xy squared. Remember, if someone says, why didn't you, like you got x and x there, why didn't you add the exponents? When do we add the exponents? When we're multiplying. When we add them, they stay the same. So negative 14xy squared plus 12xy squared is negative 2xy squared. Okay? Over 6xy. So I found common denominators. I added them together. All I got to do is my last step. What do I do at the very end of every problem? Simplify. So if I simplified this, what would I get? Negative 1/3. How about the x's? They cancel out. These are monomials, right? So they're on the outside. They're free. You can do whatever you want to with them. You just simplify them. Okay, and what about my y's? 1y on the top. Question. Yes, like this right here, this is negative 2 divided by a positive 6. So really, technically, the entire fraction is negative. Yes, very good question. Okay, how many all the way followed with me? How many halfway followed with me? How many I totally lost? Yes, okay. We've only done example 1. It's okay. Can I answer a question? It'll get better, I promise. Because when you multiply y times y, you get y squared. Because when you multiply, that's what I'm doing. I'm timesing to get the numerator. You multiply. Okay, let me do another one. You'll get it. Okay, let me do another one. Okay, it will get better. I promise you. All right, here we go. First of all, what do we know about subtraction? How many don't like subtraction? How many would rather add than subtract? Like, I don't like either one, Miss Corns, but if I had to choose, I'd rather add. Okay? So, what I do to help you out, and it's not a big deal for monomials, but it really helps when you get into binomials and trinomials. Okay? I don't subtract. Guess what I do? I add what? I add the opposite. Okay, I copy, change. Okay, what I'm going to do is I'm going to copy this down, 3BC, and I'm going to change it to addition. And all I'm going to do on step 1 is I'm going to apply this negative to the 15B. Why would I do that? So you don't forget about it. So it will eliminate careless errors. And I'm going to tell you again, it's not that big of a deal with a monomial. But when you get into binomials and trinomials, giving that negative to each piece of it helps tremendously because you won't forget about it. Okay, it will help. So let's set up our problem. What do I mean by setting up our problem?
So isn't like basically the same thing as subtraction plus the negative?
It's the exact same thing. I'm just writing it different. And again, it's not a big deal right now. But when I have a binomial up here, if I go ahead and copy, change in the very first step, if I add the opposite, then I get my signs right from the get-go. Therefore, you know what I mean? Like people forget to subtract a negative and oh, that's a double negative, that makes a positive. And then, you know, they get all confused and they forget about it and they make careless errors. So you got to trust me on this. Do you trust me? You got to trust me. When we get into binomials and trinomials, it's going to help you to copy, change with subtraction. So repeat after me. We don't subtract. We add the opposite. We don't subtract. We add the opposite. It will help. It's not a big deal right now because it's monomials, but it will help you down the road. All right, how do I set up my problem? Okay, so I draw my blanks. This is my key to success, guys. My key to success. I had some students in the past, and we were like, you know, we had gone over it on the board, and then they were up at the boards trying them, and they had the little whiteboards, and they're like, Miss Corns, I'm so lost, I'm struggling, I don't know what I'm doing. And I said, draw your blanks. And they're like, huh? I said, show your steps, draw your blanks. They started drawing their blanks, and you know what happened? They immediately started getting the answers right. It's my key to success. All right, let's find our common denominator. 15, and then I need one, at least one, of every variable I see. So what variables do we see? We see an A. We see a B. Now, this has a C and this has a C. Do I need both of them? No. Remember, you only need the most anyone has. You only got one here and you only got one here, so you only need one in your common denominator. Does that make sense? What if I had two here and one there? Then you take the biggest amount. Does that make sense? But they only have one in common. It's a common denominator. They each have a C, so all you need is a C. How many are okay with that common denominator? You okay with that? All right, so what do I need to times by? What do I need to times by 3BC to get to 15ABC? 5A. And what I times by on the bottom, I must times by on the top. How about on this side? Now, some people said, Miss Corns, can I go ahead and like start canceling some of this out? Like in the middle of my problem? When do we cancel in a problem? When do we simplify? At the end. Right now, I have not even added my problems together yet. Do you understand what I'm saying? I'm still working on the common denominator. So we've got the common denominator. Let's fix our numerators. So multiply these together first. What's 5A times 4A? 20A squared. Right? What's negative 15B times 3B? Negative 45B squared. All right. Don't start canceling. Can I cancel this A with this A? No. When do we cancel in a problem? At the end. We haven't even added. This is an addition problem. We haven't even added yet. Does that make sense? You got to do the addition or the subtraction, and then at the end, simplify. Okay? So my question is, last time they matched, and I could add them together. My question, do I have like terms here? Does 20A squared match with negative 45B squared? No. So you know how you add them together? You just write them. So this is going to make 20A squared minus 45B squared over 15ABC. If you can't put them together, you just kind of smush them together. Okay? Now, we have now added our problems together. All right, so we finished this up. We're back from lunch now, and we finished this up. We found common denominators, we added them together, and we got 20a squared minus 45b squared divided by 15abc. Here's the question of the day. Are you finished? Can you simplify something? So here's your lesson, Landon. Okay, this is what we did the other day. Okay, at this point in time, can you factor, cancel, smush anything? I've got a binomial. Can I just start marking an A out of here and an A out of there? No, why not? Because the top is a binomial. Oops. And it is protected within the binomial. And this is a monomial in the bottom. So you can't just start marking things out. Okay, do you understand that? One's in a binomial, one's in a monomial. There's so many rules to these, right? Okay, my question is, can that binomial factor somehow? Can I take a GCF out of it? Yes. So if I take a GCF out of this, I can take out a 5, and I'd be left with what? I take a 5 out of the 20. 4a squared minus 9b squared over 15abc. Now, can I now simplify anything? I see two things. What can simplify? 5 and 15. And why is it okay to simplify the 5 and the 15? Because they're on the outside. They're free. They are on the outside. So we can make this a 1 and we can make this a 3. So we now have, let me go over here. We have 4a squared minus 9b squared over 3abc. Am I finished? We took a GCF out. Can that numerator factor again? What do we know about 4a squared minus 9b squared? It's a difference of two squares. Okay, now here's what I'm going to tell you. Listen to me. We only want to factor it if at the end it will actually cancel it out. Does that make sense? We only want to factor, we only want to simplify, it's going to help us out. If I factor this into 2a and 2a and minus 3b and plus 3b over 3abc, my question is, does anything cancel? No. So here's what I'm going to tell you. If you see a difference of two squares and you factor it all the way out, I'll accept this answer. But this one is the better answer. You only need to factor and simplify if it can help you out, if it can cancel something. Does that make sense? If it doesn't cancel anything, then why are you doing it? Do you understand what I'm saying? If it doesn't cancel anything out, then why would you break it apart? So it doesn't, you could just leave it. So you only want to cancel or simplify or factor if it can further reduce. If it doesn't further reduce or simplify, then I would just leave it. So in this case, hold that question 2 seconds. Could you have left it like this? No, because you can take the 5 out and it can do what? It can simplify. So you had to do that part of it. But once you simplified it and got this, I would have left it just like that. Okay, what's your question?
So how do you know when to
Well, it's kind of like I can look at that. The more of these you do, I can look at that and I say, okay, I know that's 2a and plus 3b and minus 3b, and I know that's going to be two binomials, and I know that's not going to cancel with the monomial because it's binomial and monomial, and so I know ahead of time, like, that's not going to help me out.
So there's a monomial in the bottom.
Well, what if you can take a monomial, like what if you can take a GCF out? Then, you know what I'm saying? Like if you can, here's what I'm going to tell you. You're probably just going to have to try to factor it and see if it can cancel. And if it don't cancel, then you leave it as it was before. It's kind of like you're just going to have to try it. Okay? The more of these you do, how many are starting to get like pretty quick at factoring. Anybody starting to get fairly quick at factoring? I mean, the more of these you do, the better you're going to be getting at them. Okay? All right. So you're still saying this isn't that bad, right? How many are still with me? How many are halfway with me? Okay. Let's bump it up to some binomials. Okay? It's the same concept, just slightly different. What do we know first about this? What kind of problem is this? Subtraction. And what do we know about subtraction? Yeah, we don't subtract. We add the opposite. So the first thing that I would do is I would take the negative, I would copy, change it to addition, and take this negative and give it to the 1. It will help you out tremendously. I cannot stress that to you enough. Okay? Step 2, once it's an addition problem, set up your problem. What do I mean by set up your problem? Draw your blanks. Okay? Draw your blanks. All right. We need to find a common denominator. Now, binomials are slightly different than monomials. I still imagine with any type of variable, I still imagine I have my menu and I would like to have one of everything I see. Does that make sense? So what's one thing we see up there? It's not just an x because what? This is a binomial and what's it in? It's in a set of parentheses, so it all goes together. That's an x minus 3. That's not just an x. Do you understand that? That's an x minus 3. The quantity of x minus 3. Okay? So I need an x minus 3. What else do I do? Need. I need an x minus 1. I got to have one of everything I see. At least one. Everybody understand my common denominator? Okay. What do I need to multiply by on the first side? I've got the x minus 3. What else do I need? I need an x minus 1. Okay. What do I need to multiply by on the other side? X minus 3. Okay. My question is now, can I cancel that out? Can I start canceling now? No. When do we cancel? At the end. We got to work the problem first before we cancel. So I need to go ahead and multiply these and change my numerators. Okay? I need to fix the numerator. So this is a monomial times a binomial. How do I multiply a monomial times a binomial? Distribute. Very good. 2 times x? 2x. 2 times negative 1? Negative 2. Very good. Same thing here. I'm going to distribute. Negative 1 times x. Do you see where this came from, like, as far as helping us with our signs? Like, if I didn't copy, change, I would have just done 1 times each of those, and then my signs would be all wrong. Do you understand what I'm saying? Like, it'd get really confusing. So that's why we gave it, it's a negative 1. Negative 1 times x is negative 1x. Negative 1 times negative 3. Positive 3. All right. Now, do I need to factor this out? Some people say, ooh, GCF, let's factor it, and then I'll be able to cancel. Can I, like, factor and cancel and simplify now? No, I still have not done my problem. I still haven't even added it. It's an addition problem. We're only going to do that at the end. Don't try to cancel in the middle. That's like a highly careless error that a lot of people try to do. Okay, so let's add these together. Let's add what matches. What matches? 2x and negative 1x. So when I add 2x and negative 1x, what do we get? X. What's negative 2 and positive 3? Plus 1. Over, and just leave this in factored form, x minus 3 times x minus 1. You don't need to FOIL it out. You don't need to multiply it out. Does that make sense? You work the top, you work the numerator, add the numerator, but you just leave the common denominator in factors. Okay? Now my question is, now that we found common denominators, we multiplied to get the numerator, and then we actually did the problem. We added it together. So now we are at the point that we could possibly simplify. My question is, can anything factor? You can put them in parentheses. There is a set of parentheses around it. Sure, it's a binomial. Okay, just because it's by itself, you don't necessarily need the parentheses. Okay, we'll go to the last one in a minute, and you can ask me. Okay, let's finish this one first. So my question is can anything factor? Can anything match? Someone earlier said, can you take a -1 out and maybe cancel these two because one's positive, one's negative? And a lot of people try to do that. My question is if I take a -1 out of this, what happens to this guy? He becomes -x, and he becomes +1. My question is, would they cancel then? Are they complete opposites? No, these are not complete opposites. This is a positive x, that's a positive x. You know what I mean? They're complete opposites when you got one positive x, one negative x. And when you got one positive one, one negative one. Does that make sense? These are not complete opposites. So I don't think you're going to be able to take a -1 out. I think you're finished. Okay, you can't. If you could, factor, cancel, smush. If you could, you would, but we can't, so we're not. Okay? Does that make sense? If you could factor something out, break it apart. Let me go back for like 2 seconds and ask me your question. Okay, because these don't match. This has an a squared, and this has a b squared. They're not like terms. Does that make sense? You can only add together like terms, what matches. Okay, so over on this one, these actually match. That's the same variable raised to the same power, 2x and -1x. So you can actually add those. Does that make sense? And -2 and +3, they're just numbers, integers. You could actually add those. That's a good question. But does that make sense? Okay. So like on example 1, look at it. Oh, I don't have it up here. But if you look at it, they did match. So we did add them. But on example 2, when you're two separate things, when they are not like terms, you just kind of put them together. Okay. All right. Are you still with me? Yes? All right. Let's see if we can't get through. We got through example 6 in second block. So I would love to get through example 6. Or we got almost through example 6. We're kind of in the middle. All right. There is something different about this one. What are we focused on getting in the beginning? Common denominators. So I am focused on the denominators right now. What do you notice about one of the denominators? One of them needs to be, they have to be fully simplified before you can do the common denominator. Does that make sense? So I've got to factor them out first. And everybody says, well, why on example 3 did you not do that? Well, look at your denominators on example 3. X minus 3, could it factor? Was it already simplified? X minus 1, was it already simplified? Yes. So if they're already simplified, you can just do the common denominators. But here, I've got to factor it down first before I can locate my common denominator. So let's draw my blanks. Let's set up my problem. No need to copy, change, change. Why not? Because it's addition. It's already addition. All right. Let's factor this down real quick. Okay? Let's take a 3 out. So this would be x plus 2. Okay? Does that make sense? I got to factor the denominators down. What if the numerators and the denominators can factor? What am I focused on? Just the denominator. You only need to factor the denominators. I would not break apart the numerators because you know what you do on the next step? You put it back together. Does that make sense? So why break it apart if you're just going to put it back together? So I'm only going to break apart my denominators. All right. So I need at least one of everything I see. I see a 3. Everybody see a 3? You got to have a 3. What else do I see? I see an x plus 2. Now, do I need both of them? They each have 1, so I only need 1. Does that make sense? You need the largest amount any one has. Well, this has 1, this has 1, so you only need 1. That's what they have. They both have that in common. So you only need 1. When would I have to have 2 of them? When one of them squared? Did somebody say that? Yes, very good. If I had like 2 sets of x plus 2, like if this guy had an x plus 2 and another x plus 2, then I would have to take the bigger one. Okay, and we'll look at that in a minute. So, what do I need to times by over here? I need to times by 3. What do I need to times by on this one? Yeah, this one's easy. You're not going to really need to change it at all. So, let's times it together. What will I get? 9. What's 1 times anything? Itself, 4x plus 5. Now, at this point in time, let me ask you a question. Can I simplify the 9 and the 3? I hear a yes, I hear a no. Why not? When do we simplify? At the end. I have not done my problem. Does that make sense? Don't try to simplify in the middle of your problem. It won't happen. So at this point in time, let's add what matches. Let's add what matches. So what matches? What will I have? 9 and 5. So I'm going to have 4x plus 14. I'm going to add the 9 and the 5 and get 14 over 3 times x plus 2. All right. Here is the question of the day. You ready? Am I finished? Can I factor? What can come out of the top? Here is where you try to simplify. My question is, though, if you take a 2 out of the top, does it help you any? Let's take a 2 out of the top. What would I be left with? 2x plus 7 over 3 times x plus 2. How'd that help me? Can I cancel anything? No. So did I need to factor? Even though it could factor, did I need to? No. So I would say this is the better answer. And so, Landon says, well, how do you know if you need to? And so here's what I say. You're just going to have to try it, see if it cancels. If it cancels, then you're gold. Okay, you got it. But if it doesn't cancel, now, what if you give me this answer right here? What if you give me that? Is that okay? Will I still accept it? Yes, but what will you see on the SOL or an IA test? You'll see this guy right there. Okay, you only simplify it when it can help you out, when it benefits you. Does that make sense? When it can actually cancel something out. If nothing cancels out, why in the world would you factor it out? It's not helping you. Okay? Everybody okay? All right, let's bump it up just a little bit more. So, what's the very first thing we're focused on? Common denominators. Now, can the numerator factor, can I take a 3 out of 3x plus 3? Could I? Yeah, you totally could, but do you need to? No. Okay, so this is where you need to keep straight. Like yesterday when we were multiplying, the whole concept was factor everything we can, cancel what we can, smush it all together. But in this case, when we're adding and subtracting, my focus is on a common denominator. So you only need to factor the denominator. So I want you to take a minute and factor these denominators. So I'm going to leave this. Even though I could take a GCF out, I'm going to leave this. I'm going to factor this into x and plus 1 and plus 1 plus x minus 1, and this is going to make x minus 1 and x plus 1. Okay? Then I'm going to set up my problem. I'm going to draw my blanks. So far, so good. Everybody with me? Now, let's talk about our common denominator. I need one of everything I see, at least one. I hear, everybody agree with the x minus 1? We got to have an x minus 1 because I see an x minus 1. So you got to have that. So I need an x minus 1. My question is I got two x plus 1s here and one set of x plus 1s there. How many do you need? When you need the most that you can get. If this guy's got 2 and this guy's got 1, how many do you need? What's the most you can get out of either one? This guy's got 2, this guy's got 1. My mama told me to pick the biggest. Which one do you pick? You need 2. I have 2 x plus 1s right here. Because he has 2, I need both of them. You need the largest amount any one can give you. Does that make sense? This guy's got 2. This guy's got 1. You need to pick the bigger amount. I need 2. Do you understand that? Yes? Nod, wink, blink, something? You need 2. You totally can put squared. You totally can put squared. But some people still don't understand that x plus 1 quantity squared. They don't understand that that means 2. Does that make sense? Some people would get confused with that, especially when we cancel at the end. So, you know, if you can do it with a square, you can totally do it with a square. Okay? Some people need them individually written so that they can see what cancels with what. All right. Now, here's the question. Let's fill in our blanks. I've got 2 sets of x plus 1s here. What do I need over here? I need an x minus 1. Okay? I got 1 of each right here. I got an x minus 1. I've got an x plus 1. What do I need right there? I need the second set of x plus 1. How many understand where I got all that? Yes? No? Where did I lose you? Common denominator. Okay, so when I'm looking at my common denominator, you got to have at least one of everything you see. So I see an x minus 1, so you definitely got to have that. Does that make sense? The only other thing I see is x plus 1s. The question is how many do I need? This guy's got 2 of them. This guy's got 1. My mama told me to take the bigger amount. So how many do you need? You need to take 2 of these down here. Okay? Then, when I'm looking to see what to multiply by, I've got the 2 here. I've got the 2 down here. What else do I need up here to get to that? I need this guy. I need the x minus 1. So that's what I times by on this side. On this side, I've got 1 of each. What else do I need to make the third part? I need another x plus 1. Okay? All right. At this point in time, can I start to cancel some stuff? Can I like factor 3 out and maybe cancel an x plus 1? Something like that? No. When do we cancel? At the end. All right. So I need to go ahead and multiply these. This is a binomial times a binomial. How do you multiply a binomial and a binomial? Foil. We're going to FOIL. So I need to FOIL x minus 1, you might need scrap paper, times 3x plus 3. So I'm going to distribute. 3x times x is 3x squared. X times 3. 3x, negative 1 times 3x. Negative 3x, negative 1 times 3. What happens to my middles? They cancel. So 3x squared minus 3 is what I got. Okay? I need to do the same thing over here. Now, guys, use your brain. What do you know about x minus 1 times x plus 1? Does it look familiar to us? It looks like a difference of two squares, doesn't it? X minus 1, x plus 1. So what do you get? What's the difference of two squares for x minus 1 and x plus 1? X squared minus 1. Okay, if you don't recognize that, then you may need to FOIL it all the way out. But the outer and the inner will cancel with a difference of two squares. Does everybody understand that? All right. So my question is can I factor this back down and start canceling now? No. We haven't added them together yet. You got to finish your problem. I still have two separate things. I need to add them together. So I'm going to add what matches at the top. So what matches? What do I have? Okay, what does that give me? 4x squared and negative 3 and negative 1 gives me negative 4 over x minus 1 times x plus 1 times x plus 1. My question of the day, I know you're wishing for it to be done, but my question of the day is, are you finished? Can I factor out that top? Any? What can come out of the top? A 4. And everybody says, well, that's not going to help you. But you need to try it to see, because I think once you take the 4 out, it might foresee what do I get when I take the 4 out? And then I get x squared minus 1. So what's x squared minus 1? A difference of two squares. Oh, and will that cancel? Will that help me? Yes, it will. So I need to go one step further, and I need to factor x squared minus 1 out. So you go ahead and do that. I'm going to come up here in the top in red. When I factor that out, it's going to be x and plus 1 and minus 1 over x minus 1 times x plus 1 times x plus 1. What cancels? X minus 1, x plus 1. So what's my final answer? 4 over x plus 1. Phew! You know what someone else said earlier? They said all that work for that itty-bitty little answer. All that work for that itty-bitty little answer. Okay, I believe I'm going to stop there for today. Okay?